Thank you everyone for joining us for today's webinar. My name is Natalie Rodriguez, and I am with the Forensic Technology Center of Excellence, a program of the National Institute of Justice. Before we get started, I will go over how you can view and interact with today's webinar. The first thing I'll draw your attention to is the chat pod, which is located on the right-hand side of your screen next to the player window. The chat is the best way to communicate any questions you have regarding today's material. All questions will be retained until the Q&A session after the presentation. The chat is also the best way to let our support team know if you are experiencing any technical issues. Simply post a short description of the issues you are having, and our audience support team will assist you. If for some reason you happen to lose the audio or video during the live stream, the first thing you should do is refresh your web browser and then click the play button in the middle of the player window. If this does not work or you experience any other technical issues, please use the chat to notify our support team. You can also contact us with any customer support issues with the FTCOE toll-free number or email address located directly above the player window. We will begin today's webinar shortly, but first, please take a moment to type your location into the chat so we can get an idea of where everyone is joining us from today, as well as confirm that the chat is working properly. For today's webinar, we have Mike Russ, Lead Crime Scene Specialist at the San Bernardino County Sheriff's Department Scientific Investigations Division, presenting on Terrestrial LiDAR Scanners, Guidelines for Use in Criminal Justice Applications. Without further delay, here's Mike.
Greetings, everyone, and thank you for being here. I'm Mike Russ, and I have the privilege of taking you through the NIJ's Terrestrial LiDAR Scanning Working Group for Criminal Justice Applications Best Practices document on behalf of the TLS Working Group team. I also want to thank the members of the TLS Working Group, all of our outside technical reviewers from across the country and across the world, as well as RTI and FTCOE for supporting our work and giving us the opportunity to present the findings to you all. Hopefully everyone finds the information interesting and informative. As we all know by now, we can't do a presentation like this without disclaimers, so please take a moment to read through this disclaimer. The only information that I'd like to add is that while all the members of the TLS working group have different scanners and software that we use currently and that we're familiar with, we really did strive to come together in a vendor-agnostic way to provide and produce information and guidelines that will work for you, no matter the particular brand of scanner or software you're using today. As I'm sure is the same with most of you, I don't get to choose the scanner my agency purchases, and what I'm using now could change next procurement cycle. So any particular vendor's software or hardware you see referenced in this presentation is not an endorsement of that vendor to the exclusion of any other vendor. I also want to take a moment and talk about the International Association of Forensic and Security Metrology, or IAFSM. If you are not aware, the IAFSM is an international association dedicated to the development and use of precision measurement systems, techniques, and software in the generation of 2- or 3-dimensional coordinate spatial data for documentation, planning, analysis, and/or presentation purposes in the service of justice. I have had the honor to serve as their vice president for the last 4 years. Within the IAFSM, the discussions and work on creating vendor-agnostic best practices for TLS have been ongoing for many, many years, and thankfully, we were able to partner with RTI and FTCOE to enable this project to come together. The success of the TLS Working Group would not have been possible without the foundations previously laid by the many members of the IAFSM, past and present, who worked on these projects. For those interested, the IAFSM puts on an annual educational conference, and we have also produced the only vendor-agnostic basic laser scanning certification course for public safety personnel as part of our educational offerings. More information on those offerings are available on the website you see there. Now that that's all out of the way, Let's get to our project. Obviously, we don't have the time today to go through every single item and topic in the report, so we've done our best to select the most common areas to discuss here today. For those not already familiar, LiDAR, or light detection and ranging, is a remote sensing method that uses light in the form of a pulsed laser to measure ranges or variable distances to an area or surfaces, recording up to hundreds of thousands of data points per second. These light pulses, combined with other data recorded by the LiDAR instrument, generate precise three-dimensional information about the physical features of the area scanned. Terrestrial LiDAR scanning devices are ground-based and use their remote sensing ability to capture three-dimensional representations of a scene from multiple positions. The user then imports the multiple datasets into a given software and registers them together into one coordinate system for the scene. These unified coordinate systems often contain billions of individual data points and can produce a photorealistic representation of the scene. So now that we've captured this data, what can we do with it? Well, one thing is to produce spatially accurate scene representations for a 3D environment. Humans exist in a 3D world. That's how we understand context and spatial relationships. So using this data, you can virtually put a juror back into the crime scene as it was when you were there. Another thing we can do is produce comprehensive viewpoints. You can put the viewer literally anywhere within the scene. You can show what a witness perspective could have been. You can also produce specific reconstruction measurements and enable the investigation of how that particular event interacted with the scene as a whole, as well as allow for the visualization of that event within the scene, in the example of a trajectory path. You can also integrate results from a variety of analyses. In fact, the 3D dataset can almost become the backbone to create a visual case file where all photographs and analysis are housed. In the forensic and law enforcement community, terrestrial LiDAR scanning is most commonly used to document crime or collision scenes, especially major crime scenes or mass casualty scenes. The technology is also regularly leveraged by the reconstruction disciplines of bloodstain pattern analysis or gunshot trajectory analysis, as well as specific event reconstruction and analysis, as it allows for testing and demonstrating different hypotheses in a virtual environment. In looking at all the different forensic uses, the TLS working group were able to categorize them into 3 different areas by the intended use type. So general analysis is when the data is to be used to take overall general measurements of things like evidence, vehicle sizes, locations, buildings, and maybe perspective or sightline distances, and really any measurement where a standard level of accuracy is sufficient. Demonstrative is when measurements are not the primary consideration and the data are simply being displayed to show the overall lay of the land. And then critical measurements are those measurements which are used to inform an expert opinion in areas such as, but not limited to, bloodstain pattern analysis, crush analysis, and trajectory. It's often said a picture is worth 1,000 words. Historically, crime scene documentation has been primarily concerned with providing two-dimensional photographs and diagrams for jurors to understand a sometimes very complex crime scene. Terrestrial LiDAR scanning, however, allows practitioners to document a scene beyond simple photographs and really demonstrate accurate spatial relationships within the crime scene context for jurors in 3 dimensions. Beyond simply understanding the context of the scene, some of the critical aspects of an investigation, like line of sight or visual perspectives of those individuals involved or witness to the event in question, can now be shown objectively to validate or refute eyewitness testimony. This technology, perhaps more than any other, allows practitioners to capture and store a crime scene in perpetuity. It can then be revisited in a virtual context as often as is necessary to test different hypotheses. In this example, we can see terrestrial LiDAR scanning applied to a shooting incident reconstruction. This method allows the analyst to not only demonstrate the flight path of the bullet through the successive fired bullet defects observed in the target surfaces, but also to back extrapolate the bullet's flight path through the scene and demonstrate the flight path to the viewer. This also allows much greater ability to relate the flight path to other items of evidence within the crime scene, as well as provide opportunities for repeatability and reproducibility, as the analysis can be repeated in the virtual environment. Additionally, this data set also represents a workflow change or additional workflow flexibility in that the vehicle scene was scanned back at the laboratory and then reintroduced virtually into the data set at its point of rest. In this example, an analyst is using terrestrial LiDAR scan data to conduct bloodstain pattern analysis, specifically area of origin calculations. By using this instrumentational method, an analyst is able to select and map the ellipse shape of individual bloodstains. The analyst then uses software to calculate that individual bloodstain's flight path. By using this method, an analyst can document and calculate literally hundreds of individual bloodstains if necessary, thereby providing substantially more data to support their conclusions. Once the analyst has mapped a sufficient number of bloodstains, the software will demonstrate the calculated area of origin in 3D space within the scene, as is shown here, with the selected standard deviation applied. Additionally, this analysis is deliverable in the form of reports detailing all measurements, positions, and calculations, photographs, and videos. This type of analysis additionally provides opportunities for repeatability and reproducibility, as the analysis can be repeated in the virtual environment. I also wanted to make mention of a recently published study, ironically the same month as the TLS Working Group report, titled Implications of Three-Dimensional Laser-Scanned Images for the Criminal Justice System. The results of this study were that 3D videos were the preferred documentation method, and that respondents agreed that 3D scans should be included in jury presentations. In 2018, practitioners approached the FTCOE about creating a working group to address the following practitioners' needs. While TLS devices have been broadly adopted across the forensic and law enforcement community and are often used for documenting and reconstructing crime or collision scenes, no standardized vendor-agnostic guidelines were available for end users. The goal of the TLS working group was to develop resources that reflect consensus-based best practices that standardize and improve the use and application of TLS in crime scene documentation and reconstruction. Our hope is that this will assist in establishing a minimum standard for capture, processing, analysis, visualization, presentation, and storage of TLS data in a forensic context. So with the support of the NIJ and the FTCOE, a working group was formed in late 2019 that met both in person and virtually many times over the last 2 years to work on this project. TLS working group members included forensic practitioners, researchers, educators with extensive backgrounds in crime scene documentation and reconstruction, as well as experience in providing expert testimony on bloodstain pattern analysis, trajectory, and collision reconstruction. The working group included representatives from federal, state, county, and local systems, as well as representation from the Crime Scene Subcommittee of the OSAC, and included ISO 17025 and ISO 17020 accredited practitioners. The vision of the working group was truly to build a central repository of reference materials and supporting guides for forensic practitioners to use in their work, to use when they're advocating for resources, and to use as a guideline or backbone for establishing their own policies. The hope is that broad adoption of the working group guidelines produced will further inform practitioners as well as create a foundation for standardization of TLS technology in the forensic context. Additionally, by adopting these best practices, we hope to improve the ability of practitioners to document scenes consistently, irrespective of the particular TLS instrument that they're using, as well as provide solid foundations that enable practitioners to render scientifically supportable conclusions from their data in court for the triers of fact. So now here we are, published in March of 2022 and available on the FTCOE website. These resources are intended to help agencies create high-quality TLS programs. Among the many issues the working group addressed were things like scene operations and data collection. What should be documented? What is the intent for scanning a particular scene? What is the data going to be used for? To things like what point density is ideal for bloodstain pattern analysis versus general scene documentation versus trajectory documentation versus crash documentation. Issues like data processing, interoperability, and presentation of data. How the data should be treated. How you can ensure your data will combine accurately with other data. Other data management and storage issues. What's the best method for TLS data to be stored and maintained to ensure longevity and admissibility as evidence? One of the primary focus areas for the TLS working group was training. And what we did is establish recommended TLS qualification levels for practitioners based on what their actual functional capabilities are. And these categories are the operator, the technologist, and the analyst. So I want to take a few moments and talk about these different levels of functional capability. The first one is the operator. Broadly, the operator is trained and qualified to operate the TLS instrument, to capture data, testify about how the TLS instrument operates, how it was used to document a particular scene, as well as topics like instrument maintenance, obtaining calibrations, etc. The next functional level is the technologist. So in addition to the qualifications of the operator, they are also trained and qualified to process TLS data, produce demonstrative exhibits, integrate TLS data with other data sources, and testify about these activities. This level is likely the qualification level where most folks in the forensic community using TLS instruments will wind up. They know how to use their instrument, they know how to register their data, they know how to process and document their scene, and they're able to produce diagrams and deliverables as needed for their cases. The highest functional level is the analyst. So in addition to the qualifications of the technologist, the analyst is also trained and qualified to use TLS data or other applicable sources of metrology data to complete specific forensic analyses and thereby render expert opinions on forensic reconstructions. They are also qualified to explain their reconstruction methodology, as well as render expert opinions or conclusions about their reconstructions in their respective disciplines. Also, an important note is that qualification as a TLS analyst does not replace or supersede a robust training and mentorship program in the relevant reconstruction disciplines. The use of TLS data and the use of a TLS instrument is merely another tool for the reconstructionist to employ when performing their work. So another topic that kind of dovetails with training is quality assurance. And one of the things that the TLS working group was really devoted a lot of time to was this idea of employing a quality assurance program to your TLS program. And one of the things we feel fairly strongly about is that competency testing should be part of the introductory training program to ensure that the training was successfully applied by the individual. Competency testing should also be controlled, known result tests, and competency tests should be given at the appropriate level for the member's training, whether that's operator, technologist, or analyst. Results of the competency test should be maintained by the agency in accordance with agency procedures and guidelines. And then proficiency testing, that staff members performing casework should also be proficiency tested to their level of competency every year. The annual proficiency testing should also be known result tests that are representative of casework or casework that is directly observed and monitored by personnel qualified at the same or higher level. These tests should be given at the appropriate level for the member's training, whether that's operator, technologist, or analyst, and the results of these proficiency tests should be maintained by the agency in accordance with agency procedures and guidelines. So now let's move to another focus area, scene operations and data collections. One of the most important questions that you have to answer before you start scanning your scene is, what do you need the data for, and what are you going to be doing with the data? Are you doing general measurements or reconstruction? What are your desired deliverables? For the given intended use, what are the minimum recommended point densities at the measurement location or the area of interest? Do you have or need to use reference objects or reference measurements to validate your data? My strong recommendation is yes, you do. So depending on what you're actually trying to do or trying to get out of your data, that's going to dictate the necessary instrument settings and area to be scanned. Another portion of the scene operations and data collection is field notes. Just like everything else in forensics, it's important to document how you are scanning your scene with your scanner. We strongly recommend these activities are added to your field notes. Depending on your scanner, some of this data will be captured and recorded in the metadata, but each scanner is different, so confirm what yours is recording and fill in the rest yourself. Something that's often overlooked is the necessity for a scan plan. This simple little sketch showing your numbered scanner positions and your target positions, if you use them, can be extremely helpful when registering your data. These are especially necessary if someone else who didn't go to the scene is going to register the data. Now I'd like to turn to the data processing section of the report. Data processing in this context is a multi-step process consisting of data import, registration, outlier removal, and data export. Across all of these steps, and really the whole TLS process, one of the central themes is documentation, recording what you're doing and how you're doing it. For most TLS, data from a scan project must be imported into proprietary software for processing. During import, some filtering options may be available. You've really got to understand if there is filtering going on and the effects of these settings on the quality and accuracy of your data to ensure that an appropriate level of filtering for the intended use of the data is occurring. Registration is the term for the process of putting the different scans together into one coordinate system, and each registration software has several ways for the user to accomplish this task. Registration may be automated, both targeted or targetless, or may require manual or visual alignment of different scans or manual matching of points that are in common in the different scan positions. All of these are valid registration methods. The registration software may also provide feedback on the quality of the registration, which is great information to have. You may have NIST traceable reference objects or simply establish a ground truth by manually measuring a roadway width or a wall length to compare to your data, which are also great options. The users should also visually verify the quality of the registration by examining the alignment of common surfaces or the correspondence of common points. For example, on an outdoor scene, telephone or signal light poles are sometimes great to use to confirm registrations because from a top-down view, they should show as a circle in properly registered scans. Simple quick checks like that, along with using your reference objects or checking your data against your ground truth measurements, are very important to manually validating the accuracy of your registration. Regardless of the density of the data collected, errors in registration may significantly reduce the accuracy of distances measured between points scanned from different scan positions. So moving on to outlier removal, this is a topic that always causes some questions. I will tell you that you won't have to be scanning very long to have some other member of the investigative team walk up to the scanner or across the beam as you're scanning. I think it's happened to everyone. So because a TLS will collect data for any object within its range, including people, vehicles moving in or around the scanner, it's often necessary to minimize or hide data points from transient or non-evidentiary objects to improve the visibility of evidence or just of the scene itself. An important take-home point is that we're using tools in the software to hide those data points, but we're not deleting them, and they can be shown as needed should there be questions. Obviously, a lot of care must be taken to not hide data of evidentiary value in the point cloud. Also, important clarifying language for data reporting or presentation should include disclaimers like, extraneous data captured during the scanning process have been minimized for clarity. These data minimized are available for examination upon request. Now let me talk for a moment about data export, or providing deliverables. I still think the most common deliverable for TLS data is a top-down 2D diagram. However, increasingly, fly-through videos, 3D diagrams, animations, or just exporting your point cloud into a light viewer package are becoming standard requested deliverables of the data. Exporting the data either in its native format or in a universal format like E57 or PTS will allow for additional analysis of the data using proprietary or third-party software. Since many manufacturers have a specific export file type that cannot be opened in software from other sources, when choosing the format for the export, just be mindful of factors like file size, software compatibility, and potential deliverables going down the line. Especially in a mutual aid scenario with a major scene, have the software and deliverable conversations up front about who and how the data is getting shared. I also want to mention revision history. In addition to crime scene or bench notes, one of the ways to document the work performed is with your revision history or data restore points. While processing, registering, and minimizing outliers or extraneous points, a log or history should be recorded at each major step in the process. A brief description of the actions taken prior to the save point should be recorded for later review and repeatability, either in handwritten notes or within the registration software itself. Ideally, the manufacturer's software should be capable of automatically recording users' input and processing of the dataset as an audit trail. However, at this time, this feature has not yet been implemented by any manufacturer known to us. Moving on to talking about reporting. The reporting of TLS data may vary depending on the data's purpose, application, audience, and venue. However, accurately reporting the methods and equipment used, procedures followed for the acquisition and post-processing of the data, and quality measures utilized to ensure data accuracy will help ensure TLS data are admissible and understood by consumers of the resulting deliverables. Section C of Appendix F, Legal Considerations and Recommendations for the Use of Terrestrial LiDAR Scanning for U.S. Criminal Justice Applications, provides an overview of legal requirements for admissibility of TLS evidence. But of course, legal requirements will likely vary depending on your jurisdiction. In the basics, your reporting should include a discussion of the equipment, the make, model, serial number of the scanner or scanners used, scanner specifications and settings used, a scanner calibration certificate. In the data collection, you should include the date, time, operator, a scan plan, the total number of scans, variables specific to the scan project. For example, a battery died during scan 37 and I rescanned in the same position. Any environmental considerations that occurred throughout the data process. The sun went down and I turned the color capture off. Any data validation methods employed, known distant artifacts used, traceable artifacts used, or any ground truthing established at the scene. As far as data archival, you should identify the data transfer, hash value generation, hash comparisons, and submission into your evidence system. Within registration, you should at least cover the registration methods used, how the registration was manually confirmed, any known distance artifacts or traceable artifacts used or ground truthing, and how it was checked and confirmed, and then registration results or reports. Within post-processing, any filters applied, any data cleanup that occurred, any outliers that were removed. And then in your final deliverable production, methods for creating final deliverables, instructions for navigating deliverables, etc. As I'm sure you're all aware, the types of data we're managing is most often major case data, which comes with really long retention times and must be handled and stored correctly to ensure the integrity of the outputs and their acceptance in court. Data must be protected from loss or modification. Redundant storage of TLS data should adhere to state laws and department standard operating procedures. SWIG-DE suggests that at a minimum, at least 2 copies of the primary TLS data are created in case one fails. It is recommended that 1 copy be kept at an off-site storage space to better protect the data. If that's not possible, the data should be stored on archive quality media to ensure proper protection. TLS data are also recorded in the proprietary format of the individual manufacturer's equipment. Because cases involving TLS data can be subject to retention periods of 99 years or more, there is a good chance that the manufacturer will no longer exist in the future. That's just the world we live in. So it is recommended that an additional copy of the data be created in E57 format, which is generally considered to be a generic format. Possessing a copy of the E57 data will ensure that it is readable in the future if necessary. So now I wanted to turn to legal considerations. TLS data is evidence and must be treated like all other evidence. Thankfully, the working group had the privilege of working with Jonathan Haack, who is a barrister and solicitor with over 30 years as a Crown prosecutor, an adjunct professor and researcher, as well as an instructor for expert witnesses, to assist us in addressing the legal considerations for TLS data. He wrote a fantastic in-depth appendix addressing the legal considerations for the TLS working group document. To summarize it, in order to present the strongest case for admissibility, the following procedures should be followed. Details regarding the capture, storage, and transmission of digital scene data must be adequately documented, preserved, and available for review by interested parties. Digital scene data should not be altered between the time of collection and its use in court, and should any alteration occur, it must be fully documented. Access to original data must be restricted to qualified individuals who understand the need to preserve the integrity of the data. Integrity verification is an essential precondition. Proper chain of custody documentation requires an accounting of the chronological history of the evidence, with all steps from creation to presentation noted. Therefore, a comprehensive audit trail recording the digital lifespan of the measurement data should be maintained and available for review. A further consideration regarding the evaluation, interpretation, and presentation of TLS data is that of peer review. As you might be aware, the Supreme Court stated in Daubert v. Marodal Pharmaceuticals, everybody loves the Daubert case, that peer review is one of the factors trial judges should consider when assessing admissibility. In cases where an analyst has formed opinions about a scene based upon the evaluation and interpretation of TLS data, it is recommended that a meaningful, thorough, and documented peer review be conducted. So, moving beyond reporting guidelines, the working group also put together a list of what we feel are really required pieces of equipment for those that are still building out their TLS programs, and then another list of recommended equipment for those that may have set up a TLS program but are still looking for ways to make things easier. And a lot of them are just simple things that we've run into as we've processed all of these scenes and said, oh man, it'd be really nice if I had this. And we added it to the list. Stuff like door stops. It's incredibly handy to have a set of door stops that you can position doors where you want them as you're processing through your scene. To things like a platform tripod or the really oversized tripod feet that you can set your equipment up on sand or soft surfaces and it won't sink in or move. To things like vehicle power inverters to charge your batteries, etc. I also wanted to spend a moment talking about equipment calibration. It's a topic we spent a lot of time discussing in the working group, as we are all very aware of the frustrations of having to send your instrument out when it feels like you just got it back. But the TLS instruments, even if they're idle, require regular calibration to ensure accuracy, and that calibration cadence is set by their manufacturer. The working group looked at other ISO standards for calibration methods, calibration confirmation checks, as well as on-site check methods, but we were unfortunately unable to find anything in the current literature or standards that would be readily adopted or applicable to the forensic community. This is another area of ongoing research that should be investigated. There's a few other takeaways from the project. Vendors have made significant strides to accommodate TLS instruments being used in forensics, but there's still some outstanding needs that we identified. One of them is audit trails, like we already discussed, of having software enabled to track what a user's doing with the data set and recording that information for later discovery purposes. A calibration frequency that is more appropriate for forensic uses. And a big one is a unified description of scanner capability to facilitate on-site communication. There is often a huddle when we have a major incident and we have all these different agencies coming together and everybody brings their own kit and their own scanners and their equipment, and we all have to get together and figure out between all the different manufacturers what settings are going to be as close as possible to each other between these different manufacturers' equipment so that we're all getting as near point density as we can for the project at hand. And a unified description from the vendors that this scanner and that scanner, they both say the same information and they communicate that information in the same way would go a long way to simplifying that process. A few other things that came out of the project are, the really long retention times that this data has. I mean, there's some of these cases are 99 years or more that we have to store this data and make sure that it's still working and still valid. So vendors should consider legacy software that enables users to open old scans and work with old scans, visualize old scans, so that investigators of the future can still go back to these crime scenes and see what the scene was all about. Additionally, And along those lines, developing some kind of archive quality storage media that's sufficient to TLS project file sizes. I know some folks are using Blu-ray discs or even dual-sided Blu-ray discs where you're possible for storing 50 gigabytes of data, but there are TLS projects that exceed that. So then what do you do? So all of these are kind of considerations that hopefully will be investigated further. Well, hopefully this overview of the project has been of use to you. I want to thank you very much for your time. I know everybody's busy and short-staffed, and we're doing the best that we can do, so I really appreciate you taking the time to be here for this. Hopefully you feel like it was worth your time. Just so you're aware, we're also planning a series of web-based presentations for end users, like attorneys and administrators. So hopefully going forward, we can increase their knowledge base so that when you have the pre-trial conference with them, they're a little bit better prepared to ask the type of questions and understand what information you can provide and what deliverables you can provide and what you can really do to show your case. If you have technical questions about this project, please email myself, or if you're sick of hearing from me, you can email Rebecca. And if you have questions now is the time. Thanks very much.
Alrighty, thank you, Mike, for that very informative presentation. Today we have guest moderator Rebecca Shute with the FTCOE joining us, as well as Will Henningsen from the Omaha Police Department Forensic Investigations Unit, and Jason Keller from the Naval Criminal Investigative Service Office of Forensic Support. They were all members of the Terrestrial LiDAR Scanning Working Group and helped see the guidelines report to fruition. Take it away, Rebecca.
Thank you. Thanks so much, guys, for joining us today. Really awesome group to work with, and I'm really excited to talk through some of these questions here. Starting off with, this is a question Mike can answer. Do you have any recommendations for external agencies or organizations which have proficiency tests in place for LiDAR scanners?
So my feeling on this is it's going to be, the short answer is no, because we're not going to recommend external vendors or one vendor over another, etc. However, I think that proficiency testing is also going to be very instrument dependent and software dependent. So you need to have your folks proficiency testing on the equipment that they're using, the software that they're using, and giving a representative workflow and a representative product or deliverable to that scope of what they're expected or what you're expecting them to be able to do. That being said, I could see going forward where some organizations may create some type of analysis proficiency test given TLS data, and having kind of a standardized proficiency test for those disciplines. But for the actual data capture, I think you're going to need to have your internal agency protocols and procedures, and that you, the agency, are going to have to make sure that your people are following those.
Great, thanks so much. A question for Will. Why is the top-down 2D the most common deliverable? Doesn't that diminish the capabilities of the LiDAR?
Well, it definitely diminishes the capability to show number of measured points, but I don't know that it necessarily diminishes the value of the data set that's provided. I think it's definitely the most available and the most used deliverable because of the fact that our court systems, frankly, lag about 2 decades behind in technology when we go to display this information. We have a much easier time, even though government agencies are not known for being on the cutting edge of technology. Even internally, we're able to display and distribute this information much more efficiently and effectively than we are in most court systems. The federal court system is probably the only system that sits outside of that, and they've properly resourced it so that this dynamic visual medium can really be presented to people properly.
I'll just add something to that too. I think there's a level of comfort as well with the prosecutors. You know, trying to, when you first show them a 3D fly through or some kind of video reconstruction, they think, all right, how am I going to get this admitted? And they're much more comfortable with the 2D diagram, even if it's you know, a scale diagram, you know, using lines and symbols from the 3D data. It's still a more accurate representation than, you know, my hand-drawn sketch from the scene. But they're more comfortable with the 2D medium than they are in the 3D realm. So for us, it's a lot of education, and which is kind of what's great about this TLS working group, you know, getting this information out there, and the plan to create the webinars to educate not just, you know, the investigators, but also the legal community on how this data can be used, and how it can be admitted as evidence in a trial. I think we'll see an increase in the request for, you know, the 2D deliverables to the 3D deliverables. So.
Thanks so much. You touched on education a little bit, which goes to another question. I'm going to switch gears a little bit, but what sort of training opportunities are available for LiDAR scanning?
I can briefly touch on that one. Typically, when an agency purchases one of the scanners from whichever vendor, there's vendor training that takes place, usually a 3 to 5 day certification training. That's usually at the very basic level, and then there are some outside training sources as well for some more advanced training, such as the analysis of the bloodstain data or shooting trajectory data. Those are all you know, available by outside vendors. You know, a simple Google search can identify some of those. They're not very prolific yet, but they're out there.
Great.
I would add IAFSM to one of those organizations, right? I mean, that is really one of the primary goals that we're trying to fill. Those shoes that Jason properly mentioned are not, you know, not well represented out there, right? And not well filled at the moment. Once people get that vendor training, it's definitely shouldn't be the end of the story. We want to get that broader perspective on things and understand the technology better and how it fits into the overall forensic community.
Great, thank you. A question for Jason. How accurate is the scanner for bloodstain pattern analysis? Has this working group conferred with the OSAC blood pattern analysis subcommittee as to its potential use?
So I can say, is from the OSAC perspective, I sit on the crime scene investigation and reconstruction subcommittee, and we're planning on, now that this document has been published, we're planning on actually taking this document into OSAC under that subcommittee, chopping it up into several pieces, rewriting it in OSAC terms, and actually pushing some of this guidance out through the OSAC. So stand by for that. It's for those of you who are familiar with OSAC, it's definitely a long process through the multiple reviews, but that is the plan at this point. As it relates to bloodstain pattern analysis, there's quite a few validation studies that have been done on, you know, the applicability of using laser scan data to reconstruct bloodstain pattern analysis, particularly area of origin. I think some cast off pattern validation studies have been done, but as it relates to how it applies to OSAC, that's a little bit even further down the road. First, we need to get just the general guidelines out there for the use of terrestrial laser scanners pushed through the OSAC, and then we can get us into specifics for shooting reconstruction, bloodstain pattern analysis. So that might be a little bit further down the road than everybody would like.
Great, thank you. I know we were trying to have a little bit of clarification on this question, but we can do our best. Does LiDAR scanning work primarily for static scenes, or can it also be used for dynamic scene reconstruction?
So LiDAR scanning will allow you to create a data set that you can then use to do dynamic reconstruction, static reconstructions. I mean, as we know in the reconstruction world, all of these events are dynamic. Not very often does somebody stand there and let you beat them to death. They're moving, they're what have you. So Yes, what LiDAR scanning allows you to do is create a data set that you can then take your scene into a virtual environment and test different theories of the crime. You can validate different conclusions, and you can reproduce those analyses with different analysts. You can do all of those type of things. You can also get into the dynamic reconstruction side of having vehicles or people or what have you move through the scene as the event progresses, to really tell the story, for lack of a better term, of the reconstruction. I think that's what the question was, but that's my sense of what it is.
Great. I think we've hit all of our audience questions, but if anyone has any additional, please drop that in the chat. But we have a couple frequently asked questions, and I can dive into that. One being for Will. The guidance document says that agencies should be following manufacturer recommended calibration schedules, and that's usually once a year. If my agency can't afford to send in our TLS each year, can we make our own schedule based on how much we use the scanner, use a monthly validation procedure, and still be in compliance with this document?
I believe so. Yeah. I mean, we've found some good documentation out there from different sources that would support a testing procedure that is a rigorous check of a device's calibration. And I think it was something that was near and dear to me while we were discussing this in the terrestrial laser scan working group. I think it's a primary impediment to people adopting this technology is the ongoing costs of calibration. And we have to be fair in the assessment of the manufacturer's recommendations that they are made for an industry that puts these instruments into continuous use. And that is simply not how most forensic operations deploy them, and it's not the cadence that we deploy them at all. They're generally pretty controlled conditions, although they can be environmentally harsh. So we absolutely need to know that they operate well in the environment that we're using them in, and we can do performance checks of that on site, right? That is one of the primary recommendations that comes out of our document. And if I remember correctly, that's also in the guidance document that you should performance check your machine with a reference measurement on site every time it's deployed. So that in and of itself is a check of the instrument's accuracy, but then we have these other suggested target-based distance measurements from different positions with the scanner that at different angles to the scanner that will give you a good judge of whether or not that instrument is performing as it should be in any given environment. If you're looking for designs on those things, please reach out to us because I think we have some excellent ideas. It is a process that we're using at Omaha Police Department in order to control costs and keep our scanning program on track and as well funded as we possibly can.
Great, thank you. Another tactical question. If we don't have a newer scanner that automatically generates a hash value for each raw scan, do you recommend we hash the raw scans ourselves after removing the scans from the scanner?
I can take that one. I'm sorry, I didn't know if you directed it to me or not, Rebecca, but that's another one that I think is a good application of digital evidence hygiene, right, across any platform. I think eventually you will probably have most of the common vendors that manufacture towards a forensic market will do this internally, but there's also a line that's drawn there. You know, you've got some manufacturers are caching the data to a hard drive before writing it out to a removable device. And when does that hash take place and when is it written? We don't know, but in general, what we want is a hash checksum that's applied to that data set on the first iteration of the data before it's copied out. So if that is exported to a USB drive or if it's on the USB drive natively as it comes out of the scanner, I think those are both good options there. But we have to have that digital fingerprint so that we can meet rules of evidence, in particular federal rules of evidence, that this is an original copy of the data as it was written by and recorded by the scanner before we make any additional copies to work on or to distribute for discovery.
Great, thanks so much. I know we have just a few minutes left for questions, so I'm just gonna go back to a very high level question. That goes back to some of these great conversations we've had throughout the development of this guidance document, which started in early 2020. We were able to meet right before COVID, thank goodness. But somehow in the midst of a lot of challenges, we were able to work productively and get this done. But in some of these conversations, we've talked about like a consideration of LiDAR scanning as more of a discipline because it's rooted so well into metrology rather than just a technology. Mike, you had some good comments on that, and I would love to just have you expand upon why you think this way.
So forensic metrology is already kind of a discipline, and I think what you're going to see is over the course of the next 5 to 7 years, seeing this technology really expand within the forensic metrology environment to where it is stood up as its own discipline. And you're, a forensic metrologist, you're a bloodstain pattern analyst, you're what have you. And I think that will both benefit agencies in that I don't know that this is necessarily that it's conducive to try to have every single person in your agency trained to do this, right? That's very time consuming, very expensive to maintain proficiency at that level. It also is complex, and you have the multi-source aspect of it where you can be pulling in, I mean, this is outside of TLS, but you could be pulling in other remote sensing data sources and integrating that with your TLS data to then really produce a robust data set that will then allow you to move into analysis of bloodstain trajectory, recon, what have you. But all of those things will come from this discipline of understanding measurement and its relationship to questions of law. So I think that's, if I'm forecasting, I think that's the direction that this is going.
Great, thanks so much. I just saw one last question go into the chat, so we can take that and then close out. For anyone really, how important is the pre-registration of the data before leaving the scene?
I'll jump on that. Pre-registering data, that's something that a lot of the different vendors are coming out with, that capability. I'm of two minds about it, because while it's great to have that capability, at the same time, my registration is going to be driven by what I know about the scene and how I process the scene and how I collected data. And so I think it's a great tool to be able to visualize perhaps areas that, oops, I didn't realize that I had a line of sight issue for that particular area. So it's kind of a check on your workflow and on your data collection, but I don't think it's, I certainly don't think it's required. It's a nice thing to have, though. I'll leave it at that. Anybody else have a thought on it?
I do. I mean, I agree with Mike in that it is a really nice thing to have and not absolutely necessary. And what you've got to start thinking about is, what is the device that's being used to do those pre-registrations, and how does that impact the quality of the registration downstream? So operators will have to be aware of, the capabilities of a Windows 10 tablet or, some kind of iPhone or iPad that's being used to register this stuff. It is fantastic to know what you have and that it, at least in general, fits together before I walk away from the scene. The way I think about this is analogous to, I'm old enough at this point to have been using film photography, and the difference between film photography and digital photography, right? I have very little sympathy for people who make poor digital photographs because you know what you have before you walk away from the scene. And we used to agonize about that stuff when we were using film. Same thing with pre-registration, right? If I can see a pre-registered data set, I'm well aware that what I have is going to be workable when I get back to this, to the actual PC that I'm going to process this on and deliver data from. But that instrument is probably much more capable of performing those registrations to an accurate degree or a more accurate degree than a peripheral device that I use in the field and under all of the stress and constraints of working an active scene. So it's a really nice tool to have, and it gives you a good preview of what you've got before you walk away.
The other thing that I would add to that is you also have to consider that this is evidence that you're working with. So are you, I mean, depending on your agency, each agency may not provide you with a department issued tablet and a department issued phone. So then you get into custody and control of that evidence data. So these are all considerations that you have to make with using on-site pre-registration.
Great, thank you guys. No, I see another question, but we're going to have to wrap up. Thank you again so much for your time, to you and the rest of the working group who put in such amazing work. It's been wonderful working with you guys. For all the viewers out there, check out our guidance document on FDCOE website and have a great rest of your day. Thank you all.
Before you leave today's webinar, please participate in our short 5-minute survey. Simply click the checkbox icon directly above the chat to access the audience feedback survey for today's event. Your feedback is critical information that helps us improve our webinars and continue providing the best experience possible. We would greatly appreciate it. Lastly, across the top of the live stream window are links to our social media profiles, including Twitter, LinkedIn, and Facebook. There is also a link to the FDCOE website, the Just Science podcast, and the FDCOE newsletter registration. Like, follow, or subscribe to stay up to date with everything the FDCOE is doing in support of the forensic community. Thank you again for attending, and we hope everyone has a great day.